that stuff into Canvas so you can see our plan. All right, so we did this problem right here on Friday before we left. Let's look at this second problem that we have here. Oh, wait, you can't look at anything without the screen up, can you? Here we go. So here is the next one that we're going to look at. Okay, so if you see ones like this, and you will, that have square roots on both sides, and then you've got a number that's not underneath the square roots, these are going to be long problems. So if you do this in 4 or 5 steps, then you've done something wrong. It should take a long time to do these problems. The biggest thing I see students do wrong is you need to square both sides. And on that right-hand side, you can just get rid of the square. But on the left-hand side, a lot of times students just like get rid of the square. Say a plus 21 plus 1 or something like that. And that is going to, it'll be much easier. It won't take you very long to do the problem, which I'm telling you, you should know is wrong because these take forever. So whenever we see this squared, I'm going to write out every step. The better you get at these, you might be able to skip some of these steps right here. But this really means that we just have that written twice. Which means that to do this, we have got to distribute. Or, if you're really good at doing this in your head, you can square, double square in your head, which is great. It'll save you some time and probably keep you from making some errors, but a lot of times that's difficult for students to process in their head with all those square roots. So, when I do square root of a plus 21 times square root of a plus 21, square root of something times itself is just a plus 21. And then I'm going to multiply square root of a plus 21 times that negative 1, which is going to give me negative square root of a plus 21. If you want, you can put the 1 right there. Sometimes that helps students to have that there, but it's not necessary. Then we'll multiply here. So we'll get negative 1 square root of a plus 21. And then negative 1 times negative 1 is plus 1. To me, that's the hardest part. That's where students are usually going to mess up if they mess this up. They don't square that out correctly. They either don't try to square it out at all, or they make errors whenever they're doing that. So once you get here, these two right here can be combined and should always be able to be combined. So if I've got negative 1 and negative 1, that gives me negative 2 square root of a plus 21. And then I could combine this stuff, but I need to move it over to the other side anyway. So I'm just going to do this. I'm going to subtract that a right there to get rid of that. Subtract that 21 to get rid of it. And subtract this 1 to get rid of it. So this is actually going to be a little bit easier of a problem because what's going to happen with our a's right here? They cancel. So I'm just going to have a number left here. So I've got 12 minus 21 minus 1, and that is going to give me negative 10. Is that right? We're okay here. All right, so in this case, because that's just a number there, I can just divide off this negative 2. And so I get square root of a plus 21 equals 5. And now we're down to one that should be much more simple. Jackson, what would I do to finish solving this? I got this square root. How do I get rid of it? Yes. So I'll get a plus 21 equals 25. And then what do I have to do, Jackson? Perfect. All right, questions? So we got 4. Remember, for these, you do always want to check your answers to make sure it works. So 4 plus 21 minus 1, that's square root of 25, minus 1, so 5 minus 1 is 4. Over here, you got 4 plus 12, square root of 4 plus 12 is 16, which is also 4, so this will work out. So we've got a equals 4 is our answer. And you can check that with your calculator too instead of by hand if you'd rather. Okay, here's another one. Okay, so for this problem right here, to solve this, I could square both sides as it is right now. But if I square both sides as it is right now, then what I'm squaring on this left-hand side has 2 square roots in it, which is going to make it pretty difficult to do. Because if you do that, just think about multiplying by the square root of 2x plus 1 times the square root of 2x plus 6, which you'll have to do. You're going to have to multiply that like this, 2x plus 1 times 2x plus 6, which means you'd have to like distribute there. And it gets kind of messy whenever you do that. So I would suggest avoiding that. It can be done that way, but I would avoid it. So to avoid it, we can just pick one of these, it doesn't matter which one, and move it over to the other side. So I'm going to take this 2x plus 6 and make it a minus square root of 2x plus 6 right here. And so that will give us this. And that way we don't have 2 square roots in the same expression that we're trying to square, because that's going to give us a lot of trouble if we have that. So we would square both sides here. So we got on the left side 2x plus 1 equals, I'm going to write this twice, 5 minus square root of 2x plus 6 times 5 minus the square root of 2x plus 6. So to multiply these two over here together, we have to distribute. So 5 times 5 will give us 25. 5 times negative square root of 2x plus 6. I can't multiply those together because the 5 is under the square root and the 5 is not under the square root and the other stuff is. So I just write them next to each other to show that they're multiplied, but I can't combine them. We'll get the same thing right there in the middle. You'll notice that happens every time. You're going to get those same terms right there in the middle. And then for the last one, I'm going to have square root of 2x plus 6 times square root of 2x plus 6, which is just going to give me 2x plus 6. And so these middle two terms should be able to be combined every time, which is going to give me negative 10 square root of 2x plus 6. And the other stuff, I'm going to go ahead and subtract off over here. And so, again, this one's a little bit easier because those are going to cancel. So that's going to be negative 30 there. So we're down to just having that single square root. Reese, what would I do next? I could, but there's something that's going to make it a little bit easier. This 10 right here is not, negative 10 is not on the inside of the square root. And will it go into 30 evenly? Yeah. It will. Let's just divide it off first. So if it will go evenly, it is easier to divide that off. Now if it doesn't go evenly, you might want to square it. And so at this point, we can square both sides. So we'll get 9 equals 2x plus 6. We will subtract that 6 and divide by our 2. So we should get 3 halves or 1.5 for our answer there. For these, you always need to plug it back in to check. So 2 times 3 halves plus 1 plus the square root of 2 times 3 halves plus 6. It's going to equal 5. So here those 2's will cancel. It'll just be 3 plus 1, so you got square root of 4. And right here, the 2's will cancel, so you got 3 plus 6. You'll get 9. So 2 plus 3 does equal 5. So this one is correct. Our x equals 3 halves. Okay, questions? All right, let's look at this one. In fact, try this one on your own here for a second. Okay, so I've done this part up to here. So look at what you have and see if you have gotten the same thing to that point. Okay, questions on this first part? Okay, so you got a couple options here. I would suggest, so you got this -2 right here in front of that square root. It is going to be easier if you can divide it off, as long as it doesn't make you have fractions over here on this left-hand side, right? So will it go evenly if we divide these by -2? It will in this case. So I would divide this off. Now, sometimes it does not go evenly, and if it does not go evenly, it will be easier just to leave it there whenever you square. But if it goes evenly, I would suggest dividing it off so that it will look like this. And then we've got to square both sides again. So over here on that right-hand side, we'll just get x plus 11. Square root's finally gone. Oh, thank you. Not paying very good attention there. Okay, so on this right-hand side, I got the x plus 11. On the left-hand side, what am I going to get there? Okay, Connor, what will we get on that left-hand side? Okay, so the best thing is in your head, square, double square that, if you got that down, because you're squaring that -x, which just gives you x squared. Multiply these together, gives you -1x, and double it, gives you -2x. Square the last, which is 1. Or, if you need to, -x plus 1 times -x plus 1, distribute that. You'll get this same thing here. So this one's a little tougher than the ones we've done before because we're getting this stuff here that still has a square. So, Braden, what do we do when we have a quadratic? How do we solve that? After we square, double square, what do we do after that? Okay, we need a factor, and to factor, we got to move everything to one side. So we will subtract this x, we will subtract the 11. So x squared minus 3x minus 10. And that will give us x minus 5, x plus 2. And that will give us x equals 5 and x equals -2. Especially when you get two answers, it's really important to check those because a lot of times one of them does not work. So we want to check these. So we'll start by checking 5. We got 3 times 5 plus 10 equals the square root of 5 plus 11 minus 1. So this is going to be square root of 25 equals square root of 16 minus 1. 5 equals 4 minus 1. Does that equal? No. So 5 looks like it should be an answer, but it is not. It's an extraneous solution. Let's check -2. So I've got square root of 3 times -2 plus 10 equals the square root of -2 plus 11 minus 1. So this is going to be the square root of 4 here, and this is going to be the square root of 9 minus 1. So we get 2 equals 3 minus 1. That is true. So our only answer would be that -2 right there. So always remember to check those at the end. When you have two answers, I would say more often than not, one of them is extraneous. Although it is possible to have two answers for these. It will happen some. Questions? I got one more type we need to look at together, and then we'll have you guys do some work on your own for these. So here is our next problem. And last one for these notes. All right, so this one is different than the others because you've got 3 square roots. And these two right here are separated by a negative, so we cannot just square both sides and get rid of the square roots. Because there's no way to combine these because they're not exactly the same underneath the square roots. And so if we square something with that negative in the middle, we have to square, double square. We can't just get rid of the square roots. So I could just square them like they are right now. But if I do that, I've got this k plus 9 and the k, whereas over here I've only got a square root of 3. And the square root of 3 seems a little bit more simple. So I would suggest on this one moving that square root of k over here to the other side. So that gets our 2 most simple elements on the same side, which I think makes it a little bit easier to multiply together. So if we square both sides here, left-hand side is just going to be k plus 9. That's no problem. This is where we're going to have to write it twice. Again, if you can do it in head, that's wonderful. All right, so to multiply these together, square root of 3 times square root of 3 is just 3. What do we get when we do square root of 3 times square root of k? What's that going to give us? Okay, Hallie, what do you think? What are we going to get when we do square root of 3 times square root of k? Kind of close, but not just the 3k. So like if I had square root of 4 times square root of, well, let's not use 4 because that's a perfect square. Square root of 3 times square root of 2. I could multiply those together, but it would still be under the square root. It's going to be the same here. To add, you would have to have the exact same numbers under the square root, so we could never add those two together. We couldn't add square root of 3 and square root of 2 together and combine those. But to multiply, you don't have to have the same numbers. You just multiply about whatever is underneath the square root together, but you have to keep it under the square root. So we're going to get square root of 3k there. So this is a little different because both of those are underneath the square root. So we're going to get square root of 3k when we do that square root of 3 times square root of k. And then we'll get another square root of 3k whenever we multiply those two together. And for the last square root of k times square root of k, we'll just get a k there. And really when we do that, square root of k times square root of k, you're doing the same thing here. K times k is k squared, and it's still under the square root, but the square root of k squared would just be k because that square and the square root undo each other. Okay, questions so far? All right, here's the next question I got for you. I got to put square root of 3k plus square root of 3k together. What's that going to give me when I add those together? What did you say, Grace? No. It is 2 square root of 3k. Okay, so this is something that mixes students up, especially on a problem like this. So it's like there's a 1 out here. So if you're adding or subtracting square roots together, they have to have the exact same thing under the square root. It's just like a variable. If like you're trying to add 3x plus 3x, right? I probably shouldn't use 3x because that's what's under there. But like if I had to add 2x plus 4x, that would give me 6x. I just add the coefficients together, leave the variable the same. So here when I'm doing 1 square root of 3k plus 1 square root of 3k, I add those coefficients, the ones that are out here, but I leave what's underneath the exact same. I don't change anything about it. So it's different than our multiplying, right? Which mixes students up a lot of times. So I got 2 square root of 3k, and I'm going to subtract that 3 to get rid of it, and subtract that k to get rid of it. And so I've got 6 equals 2 square root of 3k. All right. From here, Maddox, what do we do? Good. So, and then what's after that, Maddox? Good. So we get 9 equals 3k. And then what's the last thing? Good. And as we always have to for these problems, we're going to plug that back in to see if it works. Square root of 3 plus 9 equals square root of 3 plus square root, square root of 3. This one's a little bit more difficult to check. You can check it with your calculator, which will be pretty easy, actually. But if you didn't have a calculator for whatever reason, we got square root of 12 equals, what is square root of 3 plus square root of 3? 2 square root of 3. So like, let's say we didn't have a calculator, you will, but just to think about this. If you didn't have a calculator, how can we tell if those are the same? We can break down the 12, and the 12 breaks down into 4 times 3. Square root of 4 is 2 square root of 3, so I'm getting the same thing on both sides, so I would know that's correct. Oh, you're right. We should put it in the original. I didn't look back far enough was my problem. So let's see. Now, as long as I didn't mess up on that first step, plugging it back into the second step should also confirm, but because I haven't squared both sides yet, but we should plug back into the original. I just didn't scroll back up far enough, so let's see. So if we have that, we've got square root of 12 minus square root of 3 equals square root of 3. So if we're trying to do that with without a calculator, we'd still need to break this down into 2 root 3 minus root 3. That would have 1 right there with it. So 2 minus 1 would give us square root of 3, which of course does equal square root of 3 over here on the other side. So you're right, we should plug it back into that original there. Okay, questions? All right, so your assignment for today, I did not print it off. I just have it on Canvas for you to look at because it's just a few problems. We're just going to write those down. And so it is this worksheet here. that I just copied from a different textbook that I have. And we're going to do number 75 through 82. So 75 through 82 is down here at the bottom of the page. And I have put the answers here so you can check your answers. But what I want us to do to get started in here is I'm going to pair you guys up